Hello, everyone.
Hello.
Hi, everyone.
Hi, everyone.
Welcome to the live dev mentoring. Today, the topic is solving app performance issues with instruments. Our guest today, Yuke. Hello.
Hello. Thank you for this opportunity.
Thank you for joining us. So, for how long have you been an iOS developer?
I have been an iOS developer for over 4 years, and in total, I have 10 years of experience in software development professionally.
Awesome. And let's first introduce everyone. And Mike here, another leading instructor in the academy, and Bogdan, also leading instructor in the Essential Developer Academy. And we are here to help you. So explain to us the issues you are having with performance in your app.
Okay, sure. So it is a social e-commerce application, and we have a cart. It has some dependencies both to our backend and to Shopify backend. And when we want to load the screen, like fresh launch, it is taking too long, around like 8 seconds for the first launch, which is a bit problematic. We are trying to understand the issue, like trying to.
So it takes 8 seconds just to load the cart.
Mm-hmm. Yeah, not all the time, but like in general, it can become it is reported from time to time.
Right.
Yeah, we have integrated Firebase app performance tool to monitor, and it is still under investigation to figure out.
Okay, and you say it makes requests to Shopify and another service. Which one was it?
Our own backend. Yeah, custom. Yeah.
Backend. All right. So ideally, we would help you by looking at the actual code base and doing some debugging in there.
Yeah. I would love to do that, but I asked the team and they weren't keen to share for legal reasons. So sorry about that.
All right.
But I don't have previous experience with instruments, not with time profiler, not with memory leak investigation. So even with some generic application project, if we play with the tools, I will be much more comfortable to figure out.
Okay, so you want more an overview of the time profiler instrument, right?
Yeah.
Built into Xcode instruments. So then you can go back to your code base and try to find the issue.
Yeah, definitely.
Correct? Okay.
Correct.
All right. So we're going to be using one of our code bases for this.
Perfect.
Okay. Bogdan prepared a code base with some issues, and we try to find the issues with instruments.
Yeah, thank you very much. I appreciate that.
Sure. All right. And just before we start, also to learn more about instruments, like it's a bit of a black box, it's hard to understand how it works. But if you watch WWDC, I highly recommend you watch the videos there, because every year they update this tool, they change stuff, and it's like, just to stay up to date with instruments, check the docs there and WWDC videos. Every year they improve it. So highly recommend.
Okay, noted. Will do. Thank you.
Yeah. Right. So Bogdan, I'm going to share your screen now.
Okay.
There it is.
Before we get into our repo, which we use for so many demos now, the essential feed use case repository, I just want to maybe throw a high-level view on instruments from my experience. So first of all, instruments is not a tool; it's a collection of tools. And like Caio said, each year Apple comes in and they tweak it. So maybe they add an instrument, they remove one, they change some filters, some parameters, and the big advantage of watching those WWDC sessions is you know what's available, like what are the tools which you could use, because when you have a problem, like any performance problem, you can immediately relate to, okay, where is this going? Like, do I have a memory problem? Do I have a performance problem? Is my scrolling too bad? And since there,
Network requests and
exactly,
so on.
exactly. So you kind of get a direction, and you immediately have maybe some hypotheses. You say, okay, maybe it's a performance problem. So I'm gonna use the instruments for, I don't know, time profiler, and I'm gonna give it a go and see which results do I get. And sometimes you're not gonna get anything, and because this is a hard process. Like, instrument is not gonna write on screen with bold characters like the problem is here. It's usually very complex, especially with big apps. You have to interpret these results. So,
well, if you are lucky, the tool will show you precisely the line.
yeah,
when it
It can
works,
happen,
it shows you
yes.
precisely the line. But when it doesn't show you that, then you need to debug.
Yes.
yeah. So
It may give you some hints, and then you need to find it. But when it works perfectly, it shows you, here's the problem.
Feels like magic then.
yeah.
Yes.
So that's for me, that's the foundation. So knowing which instruments are available, and then you can maybe play with a few of them just for a few minutes and see which results you get, and then you can explore more. And sometimes you even, like, to test your theory, you have to make some changes to your code to see if those I don't know, if the hypothesis is true and your problem is indeed where you think it is. And I'm gonna take a step back at the scenario you described. So if you tell me that you have a checkout screen that's loading very slowly, especially the first time, then I immediately think, then maybe it's a caching that's helping get the results, like better results on future loads, right? So that might be like one theory, which I would check would be, okay, is this related to network calls? Like, do you maybe make multiple serial network calls where you just make a request, wait for the result from your backend, and then maybe make another request, which is asynchronous to the Shopify backend, and then with that result, do something to draw on screen. So that would be one of the theories I would try to, I don't know, get the response to. Is that what's actually happening? And the reason why you see those 8+ seconds from the time you, I don't know, tap the checkout button to actually loading the screen. And if that's true, then you can have, I don't know, multiple approaches depending on the problem you're having. But where I'm getting with this is instruments will only give you like a small piece of information, and you have to like correlate it to the situation of your app, to the like all the network calls you're making, all the maybe persistent layers you're using, stuff like that.
I see what you mean.
We're going to go through some of the instrument use cases. Some are simpler, some are more complex. And like Caio said, if you're lucky, you get the response immediately. But sometimes it's just a combination. So
I really like this idea. You need to have a hypothesis first before using this tool, because you think like, where do I think the problem is? Oh, I think it's the network request. Then you have a profiler for network requests. Oh, I think it's related to memory. Then you have a profiler for memory. I think it's related to core data. You have a profiler for core data, and so on. But when I see something like 8 seconds to load some data, I think like to have an operation taking 8 seconds that is not related to network requests, it feels very unlikely based on experience. You have to do something really wrong to get the CPU stuck for 8 seconds if it's not related to slow connections. And a slow connection could be like this server, maybe your custom or the Shopify server is just too slow as well, right? Maybe Shopify, since it's a third-party app, they limit the bandwidth they send to clients. And then it's something like it's out of your control. You cannot make it faster. One thing you could try to make it faster is if we're making 3 requests to Shopify, maybe making them in parallel would speed up 1 second or 2, right? Instead of serial, if possible. But you don't have much control over Shopify. But if it's your custom backend, maybe you can talk to the backend team and say, hey, the request is quite slow. Is there anything we can do to improve it? Right? But we have a hypothesis. Maybe it's related to network requests. And then you can start there.
Yeah, I see.
And there are more general profilers as well that try to find like slowness in your application, like the time profiler, right? They will try to find operations that take a long time, regardless of why. And then you need to investigate.
Okay, I see.
To add on what Caio said, if you suspect this network problem, then you could try using the network link conditioner, which is one of the tools that's available on device. So you can use it to slow down the connection even further. And if it like the response gets even slower, then it's definitely network related. Like that's easy way to. And I really recommend you do that at least once for your app. Like just put it in a bad network and see how it performs, because users actually experience this constantly, especially when maybe they go out of their homes or go in, like switching from Wi-Fi to the data carrier and back. That's when you get slow network connections, especially, and you won't see, like, unless you're using some performance monitoring, you won't see these issues because they won't have a crash, but the user experience will be really bad. So this is a direction which I always like to explore, see how an app performs under low connectivity.
So actually also running the instruments profilers in a device, not just on the Mac. Because usually the Mac is faster, right?
Exactly. I don't face this issue on simulator a lot, but on the device, definitely.
So get the slowest device you support, like an iPhone 4S. With a very bad 3G link network conditioner, and see what happens.
Okay. I will do that. Makes sense.
Okay.
Thanks.
So for people that never use instruments, how do you get to instruments?
So you get to instruments to the profile action from Xcode, which is available to the product menu, also under the Command I shortcut. And there's one detail which I'd like to mention. So using the scheme editor, we can see the profile action and the configuration that's assigned to the profile action. This is usually release, and it's important that it's the release configuration, because if you use the debug configuration here, the debug is usually slower. Like it has all these extra information like debug symbols and all generated for debug purposes, but you won't see the real performance of your app. So if you test like profile instruments with the debug configuration, you're going to see some results which are not necessarily true for your real builds that get to your users. So that's why by default, when you create a scheme, profile will be using the release configuration. So that's an important detail. And sometimes I see projects where people just tweak this because the release doesn't build fast enough or other reasons. And then they measure and the results are probably not what they want. So this is important. And then, like I said, you use the profile action, and Xcode will build the configuration, in this case, the release configuration, and you get this menu where you can choose the templates. And let's spend a minute here just talking about what's available in this screen, because as you can see, there are multiple tools here. First of all, the activity monitor is very similar to the macOS activity monitor app, where you can see like the CPU consumption, the memory consumption, disk writes, network in, out, that kind of stuff for your app. So if you're looking for a high level, I don't know, picture of the total usage of resources, activity monitor is great for that. Allocations is also really important, and it's usually like allocations is here, and it's usually used in conjunction with leaks. So leaks will show you all the memory leaks, and we can talk about these for maybe a few seconds. Like a leak is any reference, any object that's still alive that has no reference. And it's basically memory that's allocated but cannot be deallocated because there's no more references to it. So the system cannot deallocate that memory, and they keep piling up. But from a memory consumption point of view, these are not the only bad guys. So leaks is just a type of memory problems. Another type of memory problems is zombies, which lead to crashes, and you see that in the zombies template. So these are all related, like allocations, leaks, and zombies deal with memory usage, memory problems.
Yeah, they even have the different color, right? Like
yeah,
I think it's related to that. They have the same color, orange.
Yeah.
I never noticed that. Maybe you have no leaks. Maybe you have no leaks, but you're allocating too many expensive objects, and that's taking up CPU time and memory space. And maybe reducing the amount of allocations you have in your app can drastically increase like scrolling performance and so on. So leaks is not the only memory problem you can have. Maybe using too much memory or locating too many objects in critical points in your application, like in the table views and scroll views, can be a problem. And you can use allocations to find places where you are locating too much memory unnecessarily. You may be using some caching strategy to avoid allocating too many things. Like reusing cells, for example, is a way of reducing allocation during these critical points in your application.
Mm-hmm.
Another problem which sometimes happens is you allocate too much memory at once. So you get maybe a memory warning or a crash from the system because the demand for memory is so high, the system cannot satisfy that requirement. So you're also going to see that problem here with allocations. The main point is going back to, so activity monitor is a template you would use just to get an idea of your overall app status. If you want to look at memory, the allocations, leaks, and zombies is are usually the templates to go to, and you maybe look at these kind of problems if you see out of memory crashes for your app. That's kind of how you would look into the memory consumption. If you have a screen that takes 8 seconds to load, like in your case, there might be memory problems there, but they're not super likely to come from memory issues. So you can still check it, but perhaps this scenario is gonna I don't know, push you in a different direction. Animation hitches will just show you how your UI is performing. If you have any problems with rendering cells or views or stuff like that, you can try it out. App launch will give you some statistics on your application launch times. And if you have any problems there, like if your app takes too much time to load, and there's even a watchdog exception where if you take too much time to start your app, the system will kill it and you'll see a different type of crash for that. So you can use the app launch for that. And there's a couple of instruments which are tightly connected to frameworks from Apple. So like the Core Data or SwiftUI, SceneKit, Metal, those kind of go hand in hand with the framework. So if you're using Core Data, you might use the Core Data instrument to get an idea of how Core Data is performing for you. If you're using SwiftUI, then again, the SwiftUI template is going to help you understand if you're actually doing a good job or not with these. I'll also mention a few because this is like a lot to say here. File activity for all your disk operations, inputs and outputs. You can inspect these and see if you have any problems with disk operations, and that might be another potential issue for your use case. If you're doing too much writing on disk, then it might be a disk problem as well. No, because disks are usually slower than memory, even though with recent developments, hard drives are a lot faster, but still they're a lot slower than memory operations. So if you just go to disk, write something, and then read it, it's still a round trip that's taking some extra seconds maybe. So that's something to check.
Do you have caching, by the way, in the app, in this e-commerce app? After you make this request, do you cache them somehow?
Yes.
In memory
yes.
or?
We use GraphQL for the networking layer, and we use the default parameters for caching.
Okay.
Like fetch first and then cache.
So using some library for GraphQL?
Yes.
Okay.
Are you making post or get requests for the queries?
Get.
Okay. Because by default, a lot of people use post, and post requests are never cannot use the HTTP caching. So
okay.
That's usually one of the problems people face when dealing with GraphQL queries.
Okay, makes sense.
Yeah.
And yeah, just to conclude the part about templates, we have a networking template, which is pretty recent, recently added to Xcode, maybe Xcode 12 or something like that, where you can run these to analyze all your network requests that your app is making, including it's going to show how much time it spent on each connection, the type of connection, like if it's TCP, UDP, sockets, and all these kinds of protocols, so you can better understand all the calls that your app is making. Especially useful when you're having some third-party libraries which are running rampant and making a lot of network calls. Like you mentioned Firebase. I know Firebase is one that's actually making a lot of connections. So this tool will show you these connections, and you can actually understand it better, what's happening. And last but not least, Time Profiler, which is one of the best instruments, in my opinion, that allows us to inspect stack traces and time spent in different functions, in different pieces of our code and the system framework code. And we're gonna at least try to put it to a test and see how it runs, how it performs, this time profiler. But I just went through most of these templates just to give you an idea, because each respond to maybe a different kind of problem, or sometimes they overlap a bit. If I start from this scenario that you described, like an 8-second time to load the screen, then definitely I'm going to recommend checking out Time Profiler.
Okay.
Yeah, I would start Time Profiler and then Network Profiler.
So I've chosen the Time Profiler instrument, and we actually see a very complex screen. At the top is the target device, in this case the simulator. As Caio said, you should run this on the device, especially the Time Profiler, and especially on a slow performance device where all these problems will emerge, will be even more visible. Because, for instance, if you use like an iPhone SE first generation, maybe it has only 2 cores, CPU, so it's going to take a longer time to process different things. So they're going to be super visible, that they take a long time to do. So
yeah,
and if you run on a M1 Max Ultra, then maybe you can get away with some bad performance, right?
yeah, definitely.
Yes.
Yeah, you might look with Time Profiler on an M1 Ultra and say, okay, we have no performance issues, everything looks good. And then there's the target. There's also a lot which you can say here, because if you're running on the device, you can attach yourself to a process or start a process. Like, there's multiple options, which, by the way, all the documentation from Apple covers this. In our case, it automatically selected the app from Xcode here, so the essential app, but it's not running. So I have an record button, which I need to hit. So the app will start and instruments will connect to it, and it will start gathering data. We also have, you can actually have multiple instruments working at the same time. So in this case, I selected the Time Profiler template. So we get 3 instruments, also points of interest and thermal state, which are not that useful in this scenario. So probably not worth talking about these. And yeah, there's a time scale, but more, let's just start the app and see how it goes. So I'll hit the record button, and you'll see that my app is starting, and there's multiple calls here being recorded. Let's switch back to profile, and I don't know, maybe scroll for a bit. Like, it's really important. Yeah, it is, intentionally. It's really important to decide what's your scenario, like what I'm actually testing. And each time you redo the profiling, you run the exact scenario. Like, it can be, I don't know, opening and closing a screen or scrolling through a list. Like, these are different. If you do multiple operations at the same time, you'll see a lot of stack traces here, and you actually have a harder time understanding where they come from, what's actually happening. So I recommend you like narrow down and do one thing at a time. So in this case, I want to focus on scrolling only. Okay,
yeah,
that's the
let's
only.
think about this. Like in his scenario here, let's say it takes 8 seconds to load the cart data. But maybe to get to this cart data, you need to first go to some list of products, select a product, add three products, and then you get to the cart list. If you have a good design in your application, a good architecture, you should be able to go straight to the cart data with already some predefined data. So have less steps to do in the profiler and go straight to the problem. That would be best. If you can boot your application already in a state that will simulate the problem you have. And sometimes it only happens when it's a clean install, there's no cache, there's nothing. So it's important also to replicate those issues precisely.
Okay.
Yeah. And you kind of want to see the same behavior, like that 8-second delay that you described. You want to see it when you do the profiling. So then you know you're measuring the right session, right? And like I said, this is super important, because if you go through, I don't know, 10 screens and have to log in and I don't know, load some data from the API just to get to the checkout screen, then this collection of data you're doing with the instrument can be really like polluted, if I can say it like that. It's really hard to find something in there. There would be a lot of maybe other unperformant calls, which may turn your attention to a different component, and you'll say, okay, we have this problem and that problem, and you still won't get to the checkout part. So ideally, you would run just checkout in isolation, if that's possible.
Yeah, makes sense. Sure.
Again, another super benefit of modularization and having independent modules and components where you can just pick one and run it in isolation with maybe some mock data or something similar.
Yeah.
Okay.
And that's where you see the benefits of modular design that maybe you don't see at the time of building it, but in the health of the product over time, it pays off.
Got it. Cool.
So I haven't stopped Instruments. It's still recording. I'm gonna pause it because usually you want to focus on like a window of time, and you can actually use this time scale here. You see it's up to almost 4 minutes, 3 minutes and 40 seconds of recording, and I can actually zoom in on a particular time frame. Just by looking at this graph, we see activity in the time profiler on CPU usage on this area between, I don't know, seconds 13 and maybe 27, something like this. So I can just zoom in on that. I can actually zoom in on anything if I want. Like I can just select this tiny portion between seconds 13 and 13.8 if I want to do that. And you'll see immediately that the results in the bottom of the screen match just the selected area. I'll extend this area just a bit to make sure I got all the scrolling inside, and I can actually zoom in on it. So
with the pinch gesture,
with the
right?
pinch gesture, just to see this graph better. And now at the bottom of the screen, like in this list, we have grouped by thread all the operations, all the stacks that were executed, and the actual code behind it that was executed during this time frame, which I just selected. And time profile is pretty smart because it already does some grouping for us. It sorts by weight. So my first entry will be the one that's heaviest on the stack tray, so the one taking up most CPU time. They're all grouped under the process. So in this case, the essential app process. And expanding it, you see all the different threads that were executed in that time. And I'll talk about the stack trace here in a minute. This grouping is actually controlled through the call tree selector. There's this separate by thread option, which is on by default. So if I uncheck this, I will see a different grouping of the same content. This time, threading will not be taken into account. So all the stack traces will be mapped by their I don't know, code that's being called instead of being mapped by thread. So that's a different way to look at this, and there are multiple filters which you can apply here. You can separate by state.
You can combine them as well, right?
Yeah. So combining them is really powerful, as you'll see in a second. Just want to maybe mention a few. So invert call tree is so at this how we see the stack trace right now is you see the entry point of the app in this unknown address, and then the start method called on the die LD tool, where the dynamic loading of the module is done. And then each call from there, you see the main entry point to the essential app, and then UI application main, and so on. So the exact stack trace that's being called by the system, each function that's being invoked, you see them in this order until they get through the actual code that you wrote. If we...
And usually interested with the where it end up, well, not where it started. So then you can invert, right?
Yeah, that's where I was going, because usually there's maybe 15 entries before you actually get to your app's code, like all the system calls that are being made. Like, for instance, this is starting up the run loop from core foundation, and then there's a bunch of calls inside it. So all these are system calls, which sometimes you just ignore to go through your app's code, but not always. Like, you have to still pay attention to these, because sometimes side effects from what your app is doing will cause the system frameworks to misbehave. So it's a take it with a grain of salt kind of investigation. You cannot overlook anything.
But always start from the simplest point. Always start with the simplest hypothesis. Like, you may have many hypotheses. Maybe, for example, maybe it's a bug on UIKit. Maybe it's a bug on the iOS platform. But then it's very hard to figure this out. What is simpler? Maybe the problem is in my code. So let's start with things I can control better, things that are simpler. Like, my code may be the problem. So let me look at my code first, then we look at the system, because it's simpler to debug our code than the system code.
Definitely.
So to do that, instead of doing this expand for many times, you can use the call tree option and invert the call tree. And this will almost show you calls from your app, almost, because depending on the entry, they will be different. So let me rephrase that. If you invert the call tree, you will see the furthest calls, like the deepest ones first. So it's the same stack trace, but only you're looking at it in the other order. It still doesn't.
I like to think it's like a sandwich. Like, you have the bread, which is the system call, and your code in the middle, because the system starts the application, then it calls your code. Your code does some things, and then calls the system, most probably, to do something, right? So your code is in the middle there of the system calls.
Makes sense.
Right. So one good strategy, which I recommend at least at first, to maybe eliminate the sandwich and just look at
the bread.
The bread, yeah.
Get rid of the bread and look at the actual content of the sandwich. Is use these hide system libraries at least at first, because by using this, you actually tell instruments to show you all the calls, all the code that's being executed inside your app, so excluding the system frameworks and libraries. And this can give you better maybe understanding of what's actually our app doing, instead of what the whole system combined doing.
Yeah, makes sense.
Integration, yes.
Very good.
And we still have the weight, right? We still know which are the parts that are heaviest.
Yeah. So if we still look at the weight, actually what we see here is the total CPU time spent on each of these lines and the total weight percentage. So if of course my app process is 100%, and in these, I don't know how many seconds, maybe 5 seconds is the window I selected. Of these, no, it's actually 3.8 seconds. It's written right here. And that's considered to be 100%. Then out of these 100%, 78.5% is spent on this exact call. So that's like I don't know, 3/4 of that entire time is spent in one function. So I immediately want to look at that function. So how do we get this sorting? We use the invert call tree plus hide system libraries. And I don't want to separate by thread, because if we separate by thread and there might be like the same call on different threads, especially when you do like running stuff on concurrent queues, and you won't see the result because they will be split on different threads, and it's actually the same code that's I don't know, like the one entry but executed by, I don't know, 5 threads at the same time. So it won't maybe show up with a big weight at the top. So that's how I usually start. So invert, call tree, hide system libraries. And I immediately see that in my example, we spend, like I said, 78% of the time in this specialized static UI image try make data in my app, essential app, right? So that's like an immediate red flag. Okay, you need to check that out. You need to see what's going on there, because it's a lot of time spent there. And if you select any entry here, you see the heaviest stack trace that's leading to that entry that's being selected on the left. So this is actually pretty complex. Like Xcode in conjunction with Instruments will show you something similar to a crash report, like all the calls that were added until you got to a, I don't know, specific part or specific instruction. Yeah, instruction was the word I was looking for. Thanks. So that's how you can use also the stack trace to understand, okay, I see this specialized static UI image. Where is this coming from? Like, who's making that call? Well, I can see that. That's why it's called heaviest stack trace, because there might be multiple stack traces that make the same call, but the one that is heaviest is this one. So it's coming from the main through the load resource presenter. This is usually an invocation of a closure, and through a closure we get to this UI image try make, and that's my main culprit. So I can just double tap it. Yeah. And Xcode will show me my actual source line of code that's being linked to that stack trace. So in this case, I see my try make function on an extension on UI image, and I can see that that huge CPU consumption is coming from this line. Like, it's immediately highlighted. Like Caio said, if you're lucky, then Instruments will pinpoint exactly the line causing the problem. And this is because we intentionally use this example of an API that's taking a long time to process, like this computing a PNG data from a UI image is usually something that takes up CPU time. So
and it's common to see code like this when you start debugging let's say, oh, I'm having issues like the PNG is looking a bit weird. Let me put a print here, and you forget to remove it. And this code just stays there and goes to production, you know?
Yeah.
So this is an expensive operation. If you're doing this PNG data as you're scrolling the content view, which what's happening here, you can see the lag as it scrolls. Like it's not smooth, right? The scrolling in the table view.
Yeah, and you can even use this small open file in Xcode button if you want, and it will take you to that same source file. But that's kind of the end part
Best case
of the
scenario.
yeah, where you find the culprit immediately. What we recommend here is, okay, you start with maybe those two options, and you look at the weights. If you see anything that's taking up a big percentage of the weight, like everything above, I don't know, 40, 50%, is something to investigate. So just dig, like open up the stack trace, go into Xcode, look at that code, try to understand what it does. It's really useful to have Xcode show you these percentages so you understand where the problem is coming from. But sometimes it's just it's not a simple answer. You need to look at multiple call traces and inspect them. So again, the recommendation would be start with these settings, look at the traces that have like big percentages here. If you can't find any, I would remove the hide system libraries filter and kind of take a look at the whole, the entire set of calls that's being made, because maybe there's a system call that's actually causing the issues, or some of the issues. And then you have to kind of use the stack trace to understand where that is coming from. Sometimes, like I said, if you do a bad configuration or something like that, then you might have an issue in the system framework, but that's caused by something that you did, so it can be like an indirect effect. So the most important thing here is to spot the potential I don't know, bad guys, and start to go into each one and see what's going on. Like it's there's no silver bullet here to say, okay, you just do this and you found the problem, but it should give you an understanding. And again, I think I mentioned this, it really is connected to the scenario you're running. So if you're not running this exact scenario, you might not catch the problem. Like Caio said, if you don't clean the cache, you might get nothing out of a run, So go back, delete everything, delete the cache, rerun the scenario, see how it behaves. Maybe sometimes you need to, I don't know, rotate the device or something. There can be many operations which you do, or even on the simulator, you can, I don't know, maybe simulate a memory warning, and that's when the problem starts to appear. Like there can be many causes. So if you don't spot anything on your first runs, you can try different scenarios, different ways to get there. I think it's part of the process, right? Because when your team reports an issue, it's usually QA or somebody tries up a few scenarios and they try to make something that's reproducible. So they give you like a full steps to reproducing that issue. So that's kind of important to have when you do the instruments. Otherwise, you can just run instruments and again get nothing valuable out of it, because it's measuring some wrong things.
I also like to think of instruments as like it's a fantastic tool for collecting data, right? It collects infinite amount of data and a crazy amount of data over time. And to be good at instruments, you need to be good at filtering this data. That's why we have so many templates. The templates just give you this data sorted and filtered for specific things you're looking for. So one thing, the first filter we did was in the timeline, was like we shrunk the amount of data we were looking at by zooming in a specific part of the timeline. Then we apply more filters and more filters to try to go directly to the problem. And you start expanding your filters if you don't find the problem with the most restrictive filter. Like you want to look at small data at a time, because this tool, it gets infinite amount of data. Like you could investigate just this 5 minutes we got there, you can investigate it for hours.
Yeah.
So what you'll be doing in this tool a lot is filtering and trying to look at small amounts of data at a time. So we have hypotheses and we'll be digging and filtering to prove or disprove your hypothesis.
I see. Makes
It's called
sense.
filtering.
Good data as well, the real data, not.
So real data comes from real device with a release build, right? It's important as well, which is the optimized build. Ideally using the same endpoints you'll be using. Maybe using a staging API, it doesn't reproduce the problem because the problem is in the production API, right? So
definitely
those things can make a difference as well.
Yeah, this is very useful. Makes sense.
Or maybe staging is lower because there's no, there's not a lot enough. It's just for testing. It's not for actual production ready capacity. So maybe you testing staging and QA is testing staging, saying, oh, it's very slow. Well, it's slow because it's staging, not because the app is slow. So all those things needs to come consideration as well.
Definitely.
Yeah, so if you combine this, for instance, with the networking template, you can say, okay, my calls are actually taking, 2.5 seconds just to get a response from that staging environment. So out of this 8 seconds, a quarter is spent just waiting for the network to bounce back. So there's not a lot of stuff you can do on the client side to improve that.
Yeah.
Maybe preemptively loading the data before the user actually asks for it. So when the user asks for it, it's already ready. Sometimes things are out of your control. You cannot make Shopify faster, but you can maybe proactively load the data before the user actually requests it.
Makes sense.
Is like, you find like way around, like work around the limitations you have, right? You need to be creative.
Got it.
What I also recommend is you save these runs, especially the ones where you find something valuable. You can just save them and store them somewhere, share them with your team, because then you can reload them in Instruments and look at the data again, tomorrow or in a few days, it's easier than to reset up everything.
Yeah. Try to reproduce the same thing.
Exactly. Also, you can, if it helps, you can maybe tweak up your app or your code just to do something. You can, disable caching if that's something you can do, or you can force, a reload every time, or if you start to narrow down your idea and you say, I think that's the culprit, you can even make, like sometimes I make changes to my code just to put it into a specific state, or maybe an error or something like that.
Like hard code
easier
to
replicate.
Exactly.
And do it before even opening Instruments. Try to replicate the scenario first, and when you have that sorted, then you open Instruments and go directly to the problem. Otherwise, you'll be collecting a lot of data that might be just noise.
Yeah.
So having a modular system, like a more data-driven modular system, means that you can just replicate that data that caused the problem and only load that module where the problem is, and and use the instruments specifically in that scenario, and focus, like narrow down the problem and focus on that smaller scope.
Okay. Yeah.
And sometimes you think like, I'm cleaning the cache, but I still run, and it's sometimes you're like, I'm cleaning the cache, but I open the app without internet connection, and it still shows me data, because there's also system caches that you need to configure, like URL cache. It's like a invisible cache that exists in every application that may have an influence as well. That's why sometimes even deleting the app is installing again is best.
Yes, I see. Great.
Awesome. The initial idea of the tool, like, does it make sense?
Yeah, definitely. I will try.
WWDC, don't forget.
Yeah. Yeah, I will focus on filtering better and pointing out the exact problem.
Yeah, because
Awesome.
even if you have a recorded stack trace, you can ask for help from other people. You can just
Definitely,
share
yeah.
the stack trace, and you can. That's I guess that's half of the solution is reproducing and recording that problem, and then
Exactly,
you can experiment and look at it. It's basically data analysis at the highest level.
And also it makes sense to use a low-end device to make sure I get there as
If you
easily as
have
possible.
any problem on a slow device, you're gonna see it immediately.
Yeah. Yeah, I was investigating with simulator most of the time, and I don't have an M1 Mac. I have the Intel i9, but still it's quite
pretty
fast.
good.
So
It's still pretty good.
A lot faster.
Yeah.
And they're even like if you have a problem around the performance of rendering UI. I mentioned this because different screens with different sizes have, I don't know, different performance problems. So sometimes there are certain devices that have a big resolution but like a slower CPU compared to their screen size. So if you're looking at a UI problem, you might try it on that kind of a device, maybe like an, I don't know, iPad 2, I think was one of these cases where you have like a bigger resolution, slower CPU kind of combination. So, because again, all the resources that are loaded are depend on the depth of the screen and the resolution. So,
I see what you mean.
Yeah.
It's like if your app runs smoothly on an iPhone 4S, for example, for sure it will run smoothly on the iPhone 13. But if it runs smooth on the iPhone 13, doesn't mean it will run smooth on the iPhone 4S.
Yeah. I
That's
have the
why you
same
always
habit
get
for I have the same habit for designing for smaller screens. It's another topic, not performance, but same motivation.
Yeah, and the same like with internet connection. Like if it works
Yeah.
nicely with 3G, we will work fine with Wi-Fi, but not the other way around.
Exactly. Yeah, it's I think great point to keep in mind. Well, thank you very much. This is very useful in the right direction. I will be exploring more focused and more in detail.
Awesome.
I appreciate you.
Thank you for joining us.
Yeah. Thank you very much.
Thank you.
Thank you.
All right, bye.
Take care.
Bye. Thank you very much.